if I gave you cotangent theta plus 1 over cotangent theta, what could I do with this expression to try to figure out something?
Turn cotangent.
Yeah, either one.
Turn cotangent into 1 over tangent.
Okay. Did you have a different idea, Zach?
No.
I think you did. Tell me. It wasn't wrong. Tell me. What was your idea?
I was saying, didn't you turn like cotangent back into tangent because cotangent is 1 over, or yeah, tangent is 1. You know what I'm saying?
So you were saying 1 over cotangent is what?
Tangent.
Tangent. Okay, does that mean one of them's right and one of them's wrong? No, but I told you, there are different ways of solving these problems. Okay, so don't automatically assume you're wrong if someone else starts out differently. Or if you go look at my answer key and I didn't do what you did, it doesn't mean you have to erase everything. Okay, there's different options. We can work with either one of these. What's your pick? Which one do you want to work with?
The right one.
The right one because it doesn't have fractions? Sure. Doesn't mean we're wrong if we did the other one. We can work with it just the same, but if you guys would prefer to work with this one, we will. All right. I'm really wanting to focus on like how to use some of our algebra techniques. Okay, if I told you, you actually have to add these two things together. They're not like terms, are they? What could I turn cotangent into? 1 over tangent. What else? Cosine over sine. All right, so both are viable options. Let's go ahead. I don't know that it really matters, but let's do cosine over sine. And you have to put the angle with each of them. What would I change tangent into? Okay. I kind of steered you this direction so we can see I'm adding 2 fractions. If you want to add fractions, what do they have to have? Common denominator. Okay, we can do that even with trig functions. This one has a sine theta. To look like that one, what does it need? Okay, so I would have to multiply by cosine theta on top and bottom. This one has cosine. What does it need? So I have a cosine squared theta. Make sure you're writing it like this. Do not write this. That means your angle is squared. Okay, so you put the square after the cosine. Sine theta, cosine theta. All right, looks like I've gotten an uglier problem. How does this help me? They have the same denominator, so we can put them together. Okay. Do you recognize anything right now? Yeah. Cosine squared theta plus sine squared theta is 1. We could leave our answer like this, that's perfectly fine, but you also might see me write it a little bit differently sometimes. This is the same thing as if I said 1 over sine times 1 over cosine. Would you guys agree with that? What is 1 over sine? And what's 1 over cosine? Okay. So what I ultimately found is tangent plus cotangent is equal to secant times cosecant. All right. So I really did this problem just so we could practice getting a common denominator with trig functions. So we can add those fractions together. Any questions on that? Let's look at another one. Okay. Could I jump right in and get a common denominator? Sure. But we also don't want to make life harder than it has to be. Look at what I have. 1 over cosecant. What would that be? Sine. And it was squared, so it's just sine squared theta. Plus, what would 1 over secant squared turn into?
Sine squared.
And that adds up to 1. Okay, so we certainly could have gotten the common denominator, and then you would have turned it into sines and cosines, and you would get here eventually. But look first to see, can I just do sines and cosines? Does that give me an easier problem? All right. Let's try this one. Okay. You had one on your homework that was like this. You had to square things. What do you have to do in order to square the 1 plus sine t? Write it twice and FOIL, yeah. So that gives me 1 plus sine t plus sine t plus sine squared t. Okay. You don't need the parentheses there. I just put them to kind of show you this is what I got when I squared that expression. Okay, if I combine like terms, sine t plus sine t, you just add the coefficients. So 1 plus 1 would be 2 sine t. You notice adding and if we're adding, we can add in any order. What is sine squared t plus cosine squared t? So we get 2 plus 2 sine t. And I think a couple different times on your homework you had sine squared something plus cosine squared something. Maybe not right next to each other. You might have had to add the first term and the last term to get there. But that's an important strategy. Is that one okay? All right. What are your thoughts? Almost. But in order for 1 minus cosine, in order to get that to be a sine, have to be a cosine squared. Those Pythagorean identities are the only ones where the exponents really matter. Like, if we have 1 over tangent, that's cotangent. If I have 1 over tangent squared, it's cotangent squared. But with these, it does have to be a square for that Pythagorean identity to work. So if we can't go, that'll work if there's only 1 term on the bottom. So if I had 2 things on top and just 1 on the bottom, I would say split them up. Ultimately, I'm asking you to subtract fractions. What do we need? Common denominator. What would I have to multiply this first fraction by? And this one needs over, if you FOIL on the bottom, we get 1 plus cosine and minus cosine drop. Minus cosine squared x. subtracting. So I can make this plus, distribute the negative. Since my denominators are the same, we can put them together. 1 and -1 cancel. Negative cosine x and negative cosine x will make -2 cosine x. Alright, now look at the denominator. 1 minus cosine squared would be so technically, bless you, we could leave it here, but I did want to show you another way that you might see this written sometimes. All right, we have a -2. We have a cosine x. And we have 2 signs on the bottom, right? If I separated it out like this, a -2 times a cosine over sine times a 1 over sine, is that equivalent? If I multiply the top, I still get -2 cosine x. On the bottom, I still get sine squared x. So I have -2. What is cosine over sine? Times what is 1 over sine? So you could see it written like this, but you might see it as those functions multiplied together. So we're just trying to look at a lot of the tricks that we might use in these problems. So we've seen common denominator, we've kind of seen splitting this up. Any questions on this? The next two, I'm going to ask different directions this time. All of our algebra techniques still work. So what if I asked you to factor sine squared theta minus 1? Let me ask a different question. What if I asked you to factor like x squared minus 9? What does that factor into? Okay, so if I said sine squared theta minus 1, what would go at the beginning of each of my parentheses? We get a plus and we get a minus, square root of 1 is 1. So we can factor these using any of our other techniques. All right. On F, if I had said like 2x squared plus 3x minus 1, or plus 1, how would you factor that? Flip it side. So we're going to do the same thing here. Okay, the sine squared x, that's just my variable. It's squared, so each parenthesis gets a sine x. What multiplies to 2 and adds to 3? 1, 2. And then what do we do? 2 sine x plus 1 and sine x plus 1. So far, so good. I think maybe 2 more. Any questions about these? What if I asked you to simplify this? That B with a long tail, that's a beta, it's just another Greek letter, so we might see that sometimes. Just representing any other variable. Sine beta, tangent beta divided by cosine beta. Any thoughts? Separate. Okay, which two do you want together? Okay, since this is multiplied, we can just pull it apart. Would you guys agree that if I multiply it back together, I get my original? What is sine over cosine?
Tangent.
So I have tangent beta times tangent beta, which would give me tangent squared beta. Okay, bless you. I think I'm going to stop there. We're still doing notes though, but I want you to switch to a different kind of problem. Okay? So everything we've been doing is just simplifying these expressions. And I told you today is going to get easier because we are going to switch, and instead of me just telling you simplify this thing, I'm going to give you a proof. So I am going to give you a statement and say, okay, this is true. Show me why. And so with these proofs, our strategy is a little bit different. We are not trying to work like an algebra equation where we are adding and subtracting things to both sides. We are going to pick a side, and that's going to be our goal. So my suggestion, which side looks easier? Which one has less stuff in it? The right side is probably simpler, right? What I want you to do is draw a box around it. We are not going to touch that box. That is my answer. So what we are going to do is work with this side only until I get my answer to be 1 plus tangent t. Okay, so now it's just like the problems from yesterday, except I know what my answer is. That being said, you know what your answer is. So if I just write 1 plus tangent t, I'm done. Does that work? No, it's a proof. So you have to show the work to justify it. So I know some of you hate showing work, and normally it isn't a huge deal, but it is now. You have to show the steps because you know what the answer is. All right, so if you were starting with this left-hand side, what would you do? Okay, I heard change secant 1 over cosine, and I heard distribute. So can that be our first two steps? So it really doesn't matter which one you do first. I'll go ahead and just write 1 over cosine t. So now when I distribute this, these are each just over 1. So when you multiply the tops, you multiply the bottoms. So I get sine t over cosine t plus cosine t over cosine t. Look at our goal. We're pretty close. What is sine divided by cosine?
Tangent.
Plus, what is cosine divided by cosine? 1. And then what I like to do is just box this in saying, yes, this is my answer. I showed how I got there. All right, so it's just like yesterday's problems, except you know the final answer. Any questions on that one? So we'll do a couple more, and then I will give you guys time to try some. All right. Which side would you box in? The right side. That's the easier side, so we'll box it in and we'll try to get that to be our answer. So what do you think about the left? What would you do? Okay. cotangent squared be 1 over tangent squared. Not the only options. You could have changed everything into sines and cosines. You could have used, isn't tangent squared plus 1 an identity? So at least 3 different options for where you could start on that. All right, so now if I distribute, 1 divided by tangent squared times tangent squared. Okay, and then multiply these, those get 1 over tangent squared theta. What's tangent squared divided by tangent squared? What is the reciprocal of tangent? Okay, what is 1 plus cotangent squared theta?
Cosecant squared theta.
That's one of the Pythagorean identities we wrote down yesterday. Is that one all right? Yeah. Not as obvious which side is easier this time. The good news is, if we pick a side and we get stuck, we can always go to the other side. So we're not just obligated to stay where we started. On this side, we have things divided. Over here, it's multiply. This is tangents and secants. That's a cosine. What do you want to do? Which side would you box in? Okay. I heard a couple people say right. I did hear 1 vote for left, which is fine. You can box in the left and try to work to that point as well. If I box this in, looking at it, I want cosines. So let's start, what could I change tangent to, knowing that I'm trying to get cosines? Okay, what could I change secant to? How do you divide fractions? If we do that, what happens? And so I'm down to sine squared s over 1, so just sine squared s. Look at my goal. I don't want sine. I want cosine. What can I change sine squared to? Sine squared is equivalent to 1 minus cosine squared. Okay, look at our goal. I want 2 parentheses. What do I need to do with this? Yeah, you could either come up here and FOIL that one, or we could just factor this difference of squares. So that's 1 plus cosine s, 1 minus cosine s. And we got it to work. How are we doing? It's probably not easy yet. Is it easier? Let me ask that. Feeling more confident, hopefully. Okay. So what I want to do, we've got a good chunk of time now. I'm stopping for today. I'm not done with this section yet, so I have plenty more examples to come. Yesterday's homework I told you is due at the end of class. I will probably just collect it. So if you got stuck on 1 or 2, you can ask questions. Today's assignment is on Classroom. So I did what I've done past couple chapters. I just have one big assignment posted. So you are doing section 5.2, day 1. Okay, so it's those proofs. So all of them, you know what it's equal to. You're just working to get to that point. Really try to make sure that you are using good notation, showing your work. You know what the answer is, so make sure you're showing me enough to justify how you got there.